Hello and welcome to this video all about percentages with other topics. You can find all these questions in a neat PDF file on mathsupgrade.co.uk along with all the solutions. This video is just to support you further if you need any more talking through the solutions. So the first few questions are non-calculated questions. Question 1 states that there's only red buttons, yellow buttons and orange buttons in a jar. The number of red buttons to yellow to orange is given by the ratio 7 to 4 to 9. Find out what percentage of the buttons in that jar are orange. So this question is 2 marks. What I'm going to do is I'm going to write the fraction of buttons that are orange. Since the ratio is given by this red to yellow to orange, the number of orange parts is therefore going to be 9 divided by the total number of parts, which is going to be 20. So 9 over 20 is my fraction there. Now, to get this into a percentage, I need to get the denominator of the fraction to be 100. So 20 is a factor of 100. 100 divided by 20 is 5. So if I multiply 20 by 5, I'll get 100 on the denominator. So I've got to multiply the numerator by 5 as well, which gives me 45. So this is an equivalent fraction to this. 45 over 100 is the same as 45%, since percent just means out of 100. So that question there is worth 2 marks. In question 2, I'm told that a breakfast cereal, 40% of its weight is fruit. The rest of the cereal is oats. I need to write down the ratio of the weight of fruit to the weight of oats. Give my answer in the form 1 to n. So this form here is known as unitary form. I've got to have a 1 on the left hand side, and I can have any number I want, including a decimal on the right hand side. So since 40% is fruit and the whole amount is 100%, oats must be 60%. So the ratio of fruit to oats must add up to 100, so it's 40 to 60. And now, since I've got to have a 1 on the left hand side representing fruit, I need to divide this 40 by itself. So I need to do 40 divided by 40. To get 40 divided by 40, I can just do divided by 20 and divided by 2. So to divide by 20, I divide this side by 20, which is 3, and to divide by 2, I divide this side by 2, which is 1.5. I could have divided it all by 40 in one step, but since it's a non-calculated question, that's not very straightforward to do with just 60. So the answer is 1 to 1.5, and that's 2 marks. In the second part of this question, it says that a different breakfast cereal is made only using fruit and bran. The ratio of the weight of fruit to the weight of bran is 1 to 3. I need to find out a fraction of weight of the cereal that's bran. So this is actually a straightforward question, as long as you write it as a fraction, and remembering that the denominator of the fraction has got to be the total number of parts. The number of parts representing bran is 3. So 3 would be the numerator, and the total number of parts is the total number of parts in this ratio, so that's 4. So it's 3 parts of bran out of 4 altogether, so it's 3 out of 4. The whole question there was worth 3 marks. Question 3. Veronica wants to buy 35 t-shirts. Each t-shirt costs £5.80. Veronica does the calculation 40 times 6 equals 240 to estimate the cost of 35 t-shirts. Explain how her calculation shows the actual cost will be less than £240. So this question involves estimation and obviously reasoning in this part. So if I'm going to estimate, then essentially we should be rounding each value to one significant figure. Now she rounds 35 up to 40 correctly, and she rounds £5.80 up to 6. So her rounding is correct, and it just so happens that she rounded both values up. So in real life, the actual calculation, the actual answer would be slightly less. Her answer is slightly too great. So this is the question I need to consider. Have things been rounded up or down? What effect has it had on the answer? So to answer that, I can just say the number of t-shirts and the cost of each have been rounded up. So 240 is an overestimate, and that explains how the actual cost will be less than £240. So that's the first mark there. The second part of the question gives us a special offer, and it tells us that t-shirts are £5.80 each, but if you buy 30 or more of them, then you get 10% off the total cost. So work out the total cost of buying 35 t-shirts using that special offer. So this is a straightforward question really. As long as you remember, you got to find 10% off the final amount. So also remember, this question has not got an estimation in it. This is a separate part of that question. There's no estimation here, and it actually says the actual cost. So we're going to find out the cost of the t-shirts, then we're going to find 10%, and then we're going to take 10% off. So for this, the actual cost is £5.80 times 35 t-shirts. Without a calculator, that's not straightforward to do, so I'm just going to do 580 pence times 35 t-shirts. So this is in pence. So using the column method shown here, I get an answer 20,300 pence. So this is in pence. To turn that back into pounds, I can just divide by 100. So that is £203, and that's a reasonable answer. Now I need to find 10% of this and then take it off. To find 10% of this, here's 10% as a fraction. In other words, I need to do 203 times 10 and then divide by 100. The overall effect of this is dividing by 10. So the answer is £20.3. So £20.30 is the discount I get. So that's how much I can take off this amount. So if I subtract those two using the column method, I get £182.70. Again, that's a sensible answer, and the whole question there is worth 5 marks. Question 4. Daniel bakes 420 cakes. He bakes only vanilla, banana, lemon and chocolate cakes. 2/7 of the cakes are vanilla, 35% are banana, and the ratio of the number of lemon cakes to the number of chocolate cakes is 4 to 5. Work out the number of lemon cakes that Daniel actually bakes. So for this, I'm going to split my working out section here into 3 columns. In the first column, I'm going to work out the number of vanilla cakes, since it's 2/7 of 420. In this section here, I'm going to work out the number of banana cakes, since that's a percentage of the total. And then what's left will be the lemon and chocolate cakes combined. Then I can divide that amount into this ratio, and that will tell me how many lemon cakes he bakes. So the first thing, let's find the vanilla cakes. 2/7 of 420. To find 2/7, you need to find 1/7 first, and then you need to double it. In other words, 420 divided by 7. Well, 420 divided by 7 is 60. And then, so that represents 1/7. And then 2/7 is 2 lots of 60. 2 times 60, 120. So 120 cakes are vanilla cakes. Banana cakes, well, it tells us that 35% of all the cakes are banana cakes. So I need to find 35% of 420. So 35% is the same as 35 parts out of 100. So in essence, I need to do 420 times 35 and then divide by 100 afterwards. So let's do 420 times 35 first. Using the column method, I'll get 14,700. Then divided by 100, I get 147. So what's left now is the lemon and chocolate cakes. 420 cakes are what I started with. 120 I've established are vanilla cakes. I've established 147 are banana. That leaves 153 cakes, which are either a lemon or chocolate. Now we need to work out how many of those are lemon. Well, lemon to chocolate is in the ratio of 4 to 5. So to work out the number of lemon cakes, I can write this as a fraction. The fraction of lemon cakes is 4 out of 9, since it's 9 parts altogether. So 4/9 are lemon. 4/9 of 153. So I need to do 153 times 4 divided by 9. I'm choosing to do 153 divided by 9 first, since that is easier to do. And then I'm going to times that answer by 4. If I did 153 times 4 first, that'll give me quite a big number to then divide by 9. It is possible, and I'll still get the same answer, but it's just more difficult to do. So 153 divided by 9, you can do that using short division, or you can do it mentally, and that is 17. 17 times 4 is 68. That whole question there is worth 5 marks. Question 5 involves percentages, fractions and ratios. Gavin, Harry and Isabel each earn the same monthly salary. Each month, Gavin saves 28% of his salary and spends the rest of it. Harry spends 3/4 of his salary and saves the rest of it. The amount of salary that Isabel saves to the amount she spends is 3 to 7. Work out who saves the most of the salary and show how you get your answer. So this question is worth 4 marks. Since I've got 3 different people and I've in essence got 3 different calculations, I'm going to split my work and get into 3 different columns. One for Gavin, one for Harry, one for Isabel. So Gavin's information I've outlined here in purple, Harry's I've outlined in brown, and Isabel's in green. I'm just going to imagine that they each earn £100. I'm choosing 100 since £100 is easy to find a percentage of, and £100 is easy to find a quarter of or 3/4 of, and also £100 can be divided into 3 to 7 since there's 10 parts altogether and 10 is a factor of 100. It's all a non-calculated question, so this amount I've chosen here is quite clever, but you can actually choose any value, it just might make the calculations more difficult. So let's imagine Gavin saving 28% of £100. 28% as a fraction is 28 parts out of 100 times 100. Now if I'm dividing by 100 and multiplying by 100, these two operators just cancel each other out, so end up with just 28. So Gavin just gets £28. That's 28% of 100. Harry saves a quarter of 100. A quarter of 100 is easy, that's just 100 divided by 4, which is £25. So far, Gavin definitely saves more than Harry. Let's check Isabel. So Isabel saves 3 parts for every 7 parts that she spends. In other words, she's got 10 parts in total. 3 of them is what she saves, so 3/10 is what she saves. So she saves 3/10 of her £100. 3/10 of 100 is the same as 3 times 100 divided by 10, which is 30. So Isabel saves the most out of her salary. She saves £2 more than Gavin and £5 more than Harry. The whole question there was worth 4 marks. Notice I just put in an imaginary value here. This really makes the question much easier to understand. You don't have to do it this way, but this is just how the way I tend to do it to make things easier. So that was 4 marks for that question. In question 6, I've got Costco, which sells packs of mints to shop owners. On Monday, 3 shop owners buy mints from Costco. Each shop owner buys small, medium and large packs of mints. Alan buys 400 packs of mints. 32% are small packs, 40% are large packs. Beryl buys 500 packs of mints. 3/10 are small, 1/10 are large. Charlie buys 150 small packs of mints, so that the number of small to the number of medium is 3 to 4. Work out the total number of medium packs of mints that the shop owners buy, and you must show all your working. So like the previous question, in essence this question involves percentages, fractions and ratios. And I've also got 3 different people involved, so I'm going to split my working into 3 different columns. I've outlined here in purple I've outlined Alan's information, in brown I've outlined Beryl's information, and in black I've outlined the information for Charlie. So let's work out how many are medium for Alan. Since 72% are small or large, 28% must be medium, because that's what's left over 100%. So I need to find 28% of his 400 packs of mints. So 400 times 28 divided by 100 is what I need to do. So that is going to be the same as 4 times 28, since a factor of 100 can be cancelled at the top of this fraction and a factor of 100 can be cancelled at the bottom of this fraction. So that's 112. You can do that using column method if you prefer. For Beryl, I'm told that Beryl buys 3/10 worth of 500 packs of mints, which are small, and 1/10 of 500 packs of mints, which are large. So what's left out of this 3/10 and 1/10? Well, that means 4/10 are small or large. That means 6/10 must be medium. So I need to find 6/10 of 500. So 6/10 of 500 is the same as 6 times 500 divided by 10. So I can just do 3000 divided by 10, which is 300. So Beryl buys 300 medium packs of mints. Now for Charlie. Charlie buys 150 small packs of mints, so that the number of small to the number of medium is 3 to 4. So here's the ratio here, and it's only this part of the ratio, the 3 parts here, which is represented by this 150 packs of mints. So I don't need to divide the whole ratio. I don't need to divide 150 into the whole ratio. I just need to divide 150 into 3 to work out how much each part is worth. 150 divided by 3 is 50. So each part here is worth 50. Medium, I've got 4 parts. 4 times 50 is 200. So let's look at the question again. Work out the total number of medium packs of mints that the shop owners buy. So the total number of medium packs is given by this 112, add 300, add this 200, which is 612. And that question there is 5 marks. Question 7. I've got a force of 70 newtons acting on an area of 20 centimeters squared. The force is increased by 10 newtons. The area is increased by 10 centimeters squared. Helen says the pressure decreases by less than 20%. Is she correct? Show how you get your answer. So this question here is obviously involving this formula. I'm just going to underline the key information here. So here's the key information underlined. Okay, so I need to find the old pressure, and I need to find the new pressure, and I need to see by what amount it decreases by. Well, the old pressure is given by force over area, and so that's 70 over 20, which would give us 3.5 newtons. So that's the old pressure there. Now, she says that the pressure decreases by less than 20%. So let's find 20% of 3.5. 20% of 3.5 is given by 20 hundredths times 3.5. Since it's a non-calculator, I'm going to do 20 times 3.5. 20 times 3.5 is the same as 20 times 35 divided by 10. So that's 70. So 70 divided by 100 is 0.7. So that's 20% of 3.5. Now, she says that the force is increased by 10 newtons. So that means 70 plus 10 would be 80. The area is increased by 10 centimeters squared. So 20 plus 10 would be 30. So here's the new pressure, 80 divided by 30. So that's the same as 8 over 3 by cancelling a factor of 10 on top and bottom. 8 over 3 as a mixed number is 2 2/3. 2 2/3, you should know this, is the same as 2.6 recurring as a decimal. So 2.66666. So what is the difference between the old pressure and the new pressure? Well, the old pressure was 3.5, the new pressure is 2.6, right? Is that greater than this 20% of 3.5? So is that difference greater than what I worked out here? And it is greater, right? It is greater. So this shows that she's wrong. It decreases by more than 20%. Right? Make sure you follow this question through again. If you're not sure on how I've got it, then please do look at substitution into formulae. That should help you a little bit further with this question. And that's 3 marks for that question. Question 8. Here are 3 spheres. The volume of sphere Q is 50% more than the volume of sphere P. The volume of sphere R is 50% more than the volume of sphere Q. Find the volume of sphere P as a fraction of the volume of sphere R. So here, in essence, I've got a repeated percentage increase. Let me just set this up with multipliers. So here's the volume of P, volume of Q, volume of R. Okay, so you can see if this volume of Q is 50% more than this, then the multiplier is 1.5. and similarly from volume Q to volume R, it's increased again by 1.5 as a multiplier. So overall, relating volume R to volume P, I'm going to write an equation here. Volume R is 1.5 times 1.5 times Vp. So that 1.5 times 1.5 is 2.25. If you're not sure how I've got that, just think of 15 times 15. 15 squared is 225, and then divide by a factor of 10 and a factor of 10 again. So now I need to write down the volume of P as a fraction of the volume of R. The volume of P, the fraction of the volume of R, is given by this equation here. So what I've done here, I've just rearranged this top equation. Okay, so what I've done here, I've divided by the volume of R on both sides. Okay, and then I've divided by 2.25 on both sides. So that gives me Vp over Vr is 1 divided by 2.25. Now, what is 1 divided by 2.25? I need to basically neaten up this fraction. To neaten up this fraction, okay, I'm going to double the top and double the bottom. That gives me 2 over 4.5. That's still not very neat. It's still written with decimals in there. So again, I'm just going to double the top and double the bottom. So double the numerator, I'll get 4. Double the denominator, I'll get 9. So Vp is a fraction of Vr is 4 over 9, 4/9. That question there was worth 3 marks. Question 9. This question confused a lot of students. I'm told that diagram shows a shape made by overlapping 2 identical squares. The areas of the shaded region is 25% of the area of each square. Work out what fraction of the area of the whole shape is shaded. First of all, 25% is the same as a quarter. So if I set up the diagram like this, and I just show that for this square, this shaded part is a quarter of the whole thing. So this leaves 3/4 here of this square. And similar for this square, I've left 3/4 of that square, which is unshaded. Now, the shaded divided by the total is what I need to write down. The shaded part is a quarter. The total part is 3/4 plus a quarter plus 3/4. Now I need to neaten this whole thing up, so I'm just going to add those fractions on the denominator together. 3/4 add 1/4 is a whole. A whole add 3/4 is 7/4. In other words, just add the numerators together. So that's a quarter over 7/4. This line here is called a vinculum. A vinculum just represents divide. So in other words, I'm doing a quarter divided by 7/4. So a quarter divided by 7/4. How do I divide 2 fractions? What I can do is I can get the first fraction and multiply it by the reciprocal of the second. The reciprocal is in essence this fraction upside down. If you're not sure why that is, be sure to look at my video clips on dividing fractions. But in essence, the answer to this is given by a quarter times 4/7. So I can just now cancel these 2 4s and I'm left with 1 over 7. So 1/7 of the area of the whole shape is shaded there. So that question there is worth 3 marks. Now you could also do this by inspection. You've got here, in essence, 3 parts, 1 part and 3 parts. I can say that because they're all equal parts. Just look at the ratio. So in essence, I've got 1 part here in the middle divided by 7 parts in total. And that's why this fraction makes complete sense. This is an easy 3 marks if you know how to do it. If you don't know how to do it, it can be quite difficult. Question 10. In a company, the ratio of the number of men to the number of women is 3:2. 40% of the men are under the age of 25. 10% of the women are under the age of 25. What percentage of all the people in the company are under the age of 25? This is a difficult question. The way I'm going to approach this question is using kind of like a tree diagram. First of all, I'm going to write that ratio that I know of men to women. So So here's men to women, 3 to 2. The next thing I'm going to do is going to branch off the men, the under 25s, and the people that are not under 25. Well, I'm told that 40% of the men are under the age of 25. So this is 40% here. 40% of 3 parts out of 5 altogether. So 40% of 3/5. So 40% of 3/5 is given by this calculation here. So 40% of 3/5, I can work out this by just doing 40 hundredths times 3/5. 40 times 3 is 120, and 100 times 5 is 500. So 120 out of 500. I'm not going to cancel this yet, and you'll see why in just a moment. Now for the women. I know that I've got 2 parts here out of 5 altogether, which represents women. What percentage of people in the company are under the age of 25? So the women that are under 25, that's 10% of them. So 10% of this 2/5 are under 25. So 10% of 2/5 is the same as 10 hundredths times 2/5. Let's times the numerators together to get 20. 100 times 5 is 500. So 20 over 500. Now, I need to do the total of all the people in the company under the age of 25. And then I'm going to turn it into a percentage. So the total as a proportion is given by 125 hundredths, add 25 hundredths. So that's 140 500ths. This is written as a fraction. And we've done really well to get this far. But let's just finish it off by writing it as a percentage. So 140 500ths is the same as 14 50ths by cancelling 10 on the top and bottom. 14 50ths is the same as 28 hundredths, which is 28%, which is 4 marks for that question. Question 11 involves histograms, which is really a grade 8 topic. So if you need to, look at the video clip on histograms before you attempt this question. So this histogram gives information about the heights in meters of the trees in the park. The histogram is incomplete, so in essence we've got a bar missing here. 20% of the trees in the park have got a height between 10 and 12.5. So that's representing this width here. None of the trees have got a height greater than 25, so there's no information missing on this side. And clearly there'll be no information missing here, since you can't have a negative height. Complete the histogram. Remember, a histogram gives us the frequency from the area of each bar. So if I can find the areas of these bars, that'll be a good start. So let's do that now. I'm calling these bars A, B, C, D and E. D is missing. So the area of A is just given by the frequency density times by the height, or in other words the class width. So the frequency density of section A is 1.2 and the class width is 2.5. So that's 2.5 times 1.2. You should be able to do this without a calculator. You can just do 25 times 12 and then divide by 100, which gives you 3. I'll do the same method really for B, C and E, and I get these frequencies here: 3, 5, 14 and 10. Now the next part of this question is all about using this information here. 20% of the trees in the park have got a height between 10 and 12.5. So from that information there, I can say that the total area that's currently shaded is 80% of what should be shaded. The total area that's currently shaded is 80% of what should be shaded. So if I need to find out what should be shaded, and then I can find out what bar to draw here, I can just divide both sides of this equation by 80%, which is the same as 0.8 as a multiplier. So let's find the total area that's shaded. The total area shaded is given by all of the sum of these 4 sections here. So that is 32, and 32 divided by 0.8. So 32 divided by 0.8 is 40. If you're not sure how I've done this, you can just do 32 times 10 and 0.8 times 10, which is 320, divided by 8, which is 40. Now what I need to do is need to realise that 40 is what the total area of all the bars here should be. but I'm missing bar D in the question. So I know that the areas of these existing bars is 32. So this bar D should have an area of 8. So I need to work out now the height and the width of this bar D. Well, I know the width here is given by 2.5. So to find the frequency density, which is given by this formula here, I need to do the area, which is 8, divided by the width, which is 2.5. And the answer there is 3.2. If you're not sure how to do that, try using short division, or just simply manipulate this fraction so that you can multiply the top by 2, multiply the bottom by 2. That will give you 16 divided by 5, which is 3.2. So the last thing we need to do now is complete the histogram as asked in the question. The frequency density, in other words the height, needs to be 3.2. So here you can see I've drawn the height of this bar as 3.2, and obviously the width is 2.5. So that question there was a really tough question, but in essence that's how you do it for 3 marks. The remainder of the questions in this booklet are calculated questions. Question 12 is worth 3 marks. You're given a right angle triangle and you're asked to find the size of an angle. Straight away that should tell you that this question involves trigonometry. If you're not sure on what trigonometry is, then feel free to look at my video on this channel on trigonometry. I'm told that the length of QR is 60% of the length of PR. I need to find the value of sin of QPR, this angle here. So let's just label the angle there, and let's label the lengths of QR and PR from the point of view of this angle. So imagine you're standing on this angle. This side is opposite to you, it's face to face, so it's opposite. This side is next to you, it's adjacent. So since QR is 60% of PR, I can say QR divided by PR equals 60%, which is 0.6. Now, since tan is equal to the opposite divided by adjacent, the opposite is QR, PR is adjacent, so opposite over adjacent is 60%, which is 0.6. So the tan of QPR is 0.6. I can now use inverse tan, shift tan on my calculator to find the size of that angle. So that is 30.96. Now all I need to do is find the sin of the angle. So since sin of 30.96 is 0.514496, the last step is just to round it to 3 significant figures for those 3 marks. Question 13. I've given a diagram showing a rectangle ABCD and a circle. BC is the diameter of the circle. Calculate the percentage of the area of the rectangle that's shaded. Give your answer correct to 1 decimal place. So this question obviously involves areas of rectangles but also circles. So if you're not sure on how to find the area of a circle, then feel free to look at my video clip on this channel on that topic. I'm going to find the area of the rectangle, then I'm going to find the area of the semicircle here, then I'm going to find the area which is shaded by subtracting those 2 values, and then I'm going to convert that into a fraction of the rectangle which is shaded and turn it into a percentage. So there's essentially 4 steps here. So here's my 4 steps. First of all, the area of the rectangle. The rectangle is given by 19 by 16, so 19 times 16 is 304. The area of the circle is given by this formula here, pi r squared. You've got to be careful here because the radius is half of this diameter. The diameter is 16, half of that is 8, so pi times 8 squared, 100.53. So this is the area of the rectangle, the purple area here. The brown area is the area of the semicircle. So the area which is shaded is just, we can find that out by just subtracting those 2 values. So that gives us 203.46. Now read this statement here, the percentage of the area of the rectangle which is shaded. Let's find the fraction of the area of the rectangle that's shaded. So this is the area that's shaded. We need to write that as a fraction over the area of the rectangle. The area of the rectangle is 304 as I found earlier. So that's it as a fraction. To turn it into a percentage, I just need to find this as a decimal and then times it by 100%. and that is 66.9% to one decimal place for 4 marks. Question 14. This question involves volumes of prisms as well as percentages. I'm told that the diagram shows an oil tank in the shape of a prism. What that means is this shape here, this cross section, goes all the way through that shape. That's important when I find the volume. I'm told that the dimensions are on the diagram here and that it should only be filled to 85% of its capacity. The tank's empty at the start. Oil flows into the tank. After 1 minute, there's 300 litres of oil in the tank, so that means 300 litres of oil flow in the tank each minute. Assuming that the oil continues to flow in the tank at that rate, we need to work out how many more minutes it takes for the tank to be 85% full of oil. Bear in mind, 1 minute has already elapsed. So we need to essentially find how much oil can fit into here in total. Then we need to find 85% of that. And then we need to find the total amount of time it takes to fill that amount of oil. Remember to take off 1 minute, since 1 minute is already elapsed. So here's some important formulae. The first one is the area of this cross section here. This cross section is a trapezium, and the area of a trapezium is given by the mean of the parallel sides multiplied by the distance between them, the perpendicular distance there. In other words, A add B, 3 add 1.4, divided by 2 to find the mean, and then multiplied by the perpendicular distance, which is 2.4. That gives us a value of 5.28. That's the area of this face here, 5.28. Now that I know the area of that cross section, I can multiply it by the distance going backwards. I can multiply it by 2.5. That gives us the volume, the total possible volume of that shape. That's 13.2 meters cubed. Now, I need to convert that into litres, since later on I've got this flow rate which talks about litres rather than just meters cubed. I'm told here 1 meter cubed is 1,000 litres, so if I multiply this by 1,000, I'll get 13,200 litres. That's a total possible capacity of this tank. Now, I can only fill it to 85%. That's a safe fill limit, so I need to find 85% of that capacity. 85% of that is 11,220. The total time taken to fill it, well, to find that out, I need to divide this capacity by the flow rate. Since 300 litres of oil flow into it in 1 minute, to find the number of minutes, I need to divide the capacity by this 300 to give me the number of minutes taken to fill this tank. Then just subtract 1 minute, since 1 minute is already elapsed, and that gives us 36.4 minutes. The question doesn't say in minutes or seconds, so 36.4 is absolutely fine to leave it like that, and that would give you your 5 marks. The next part of the question is a reasoning question. It says the assumption about the rate of flow of the oil could be wrong. Explain how that could affect your answer to part A. Quite simply here, they're saying that we assumed 300 litres of oil flow into the tank per minute. So if that flow rate is higher, it will actually take less time. If that flow rate is lower, it will take more time. So that's just what I've written here, and that's all you need really for that 1 mark. The entire question there is worth 6 marks. Again, if you're not sure about volume, be sure to check out my video on volume of 3D shapes on this channel. Question 15. Harley's house has a value of £160,000. Correct to 2 significant figures. Write down the least possible value of the house, and then write down the greatest possible value of the house for 1 mark each. So the first part, in part A, all this involves is essentially bounds. If you're not sure on how bounds are done, then be sure to look at my video clip on that, which is on this channel. With bounds, essentially I'm told this number has already been rounded. What could the lowest possible number have been before it was rounded, and what could the biggest possible number have been before it was rounded? So I'm just drawing here a number line to represent this number. So this is the rounded value. The greatest possible value it could have been, the upper bound, is 165,000, or actually just less than 165,000, and the least possible value is 155,000. Since these are the limits, if you round each of these to two significant figures, you get 160,000. So there's my answers there. In actual fact, the part 2 one would actually be £164,999.99, but this answer here is absolutely fine in the mark scheme, since they know that since they can tell that you understand what you're doing. In part B, I'm told that the value of Rita's house increased by 5%. Her house then had a value of £210,000. Work out the value of her house before the increase. So this question involves reverse percentages. Again, if you're not sure on reverse percentages, then be sure to check out my video clip on that topic. In essence, what I'm told here is that we don't know what the value was before it was increased by 5%, but we know the value after the increase. Since 5% increase is represented by a multiplier of multiplying by 1.05, I need to do the inverse of multiplying, which is dividing by 1.05. So I need to do 210,000 divided by 1.05, and that would give me 200,000. I can always check this answer by increasing by 5% and seeing if I get that value. The whole question there is worth 4 marks. Question 16. This is 5 marks and it involves 2 or 3 different topics. First of all, it involves areas of sectors. It also involves areas of non-right angle triangles involving trigonometry. And finally, it involves percentages. If you're not sure on areas of triangles with trigonometry, then be sure to check out advanced trigonometry on this channel. So let's read through the question for these 5 marks. AB is a chord of a circle centre O. That means it's a straight line going from edge to edge. What that also means is that AO is a radius and OB is a radius. The radii are 30 centimeters each, so they're both 30 centimeters. What that means is this is essentially an isosceles triangle. I'm told that angle AOB is 80 degrees, so these angles at A and B must be equal. Work out what percentage of the area of the circle is shaded. So I'm going to find the area of the sector of this circle. So that's the whole area including that shaded part there. Then I'm going to find the area of this triangle. I'm going to subtract them through to get the area of the shaded part. And then I'm going to write that as a percentage of the whole area of the circle and then turn it into a percentage. So let's find the area of the shaded region. To find the area of the shaded region, I'm going to find the area of the whole sector here and subtract the area of the triangle. The area of the sector is given by this formula here. It's a proportion of the whole circle's area. The proportion is given by 80 over 360 degrees, and that's times by pi r squared. Since the radius is 30, I can work that through and I get 200 pi. The area of the triangle, I cannot just simply do by doing base times height divided by 2, since I don't know those values. But I can use this formula here. This applies even to non-right angle triangles. It's half of 2 sides of the triangle and the angle and the sine of the angle between them. So half of 30 times 30 times by the sin of this angle here, sin of 80. That gives me 443.1. If I subtract them through, I'm essentially cutting away this triangle from this whole sector here, which gives me 185.15. Now let's write that as a fraction of the area of the circle that's shaded. The area of the circle that's shaded is just given by pi r squared. So 185.15 divided by pi r squared. To turn that into a percentage, I just turn that into a decimal with a calculator and times it by 100%. That gives me 6.555 marks. If you struggled with this question, remember this topic here on areas of triangles, non-right angle triangles, is a grade 7 or grade 8 topic. So bear that in mind and be sure to look at my video on this channel for further support. Question 17 is similar to question 16 in that this involves the area of a sector and it also involves the area of a non-right angle triangle using trigonometry. ONQ is a sector of a circle with centre O and radius 11. A is the point on ON and B is the point on OQ, such that AOB is an equilateral triangle of side 7. Calculate the area of the shaded region as a percentage of the area of the sector ONQ. Give your answer correct to 1 decimal place, and this is for 5 marks. So I'm going to find the area of this shaded region here by finding the area of this entire sector and subtracting the area of this non-right angle triangle. When I've done that, I then need to write it as a fraction of the area of the whole sector and then turn it into a percentage. So let's start off by just recognizing this is an equilateral triangle. Because it's equilateral, that means this angle here must be 60 degrees, since these 3 angles are equal and they sum to 180. So this is 60 degrees, and we also know that the length of the side of this triangle is 7. We also know the radius of the whole sector is 11. So we can use those to substitute into these formulae here and find the area of the shaded region. So 60 is the angle here, divided by 360 times by the area of the circle, pi r squared, gives us the area of the sector, 63.36. The area of the triangle is given by half AB sin C. Again, if you don't know how to do this, look back at the video clip on advanced trigonometry on this channel. So half times 7 times 7 times the sin of 60 gives us 21.22. So the area of the shaded region is gained by subtracting those two values, and I get 42.14. Now, if I write that as a fraction of the area of the whole sector, that'll be 42.14 divided by 63.36. So that was what it is as a fraction. To turn that into a percentage, I'm just going to find that as a decimal by dividing and then times by 100, and that will give me 66.5% to 1 decimal place. Question 18 is worth 3 marks and it involves ratios as well as percentages. On a school trip, the ratio of the number of teachers to the number of students is 1 to 15. The ratio of the number of male students to female students is 7 to 5. Work out what percentage of all the people on the trip are female students. Give your answer to the nearest whole number. So this ratio is actually going to be part of this ratio here. If I set up the problem like this, you'll see what I mean. So teachers to students is 1 to 15. Male students to female students is 7 to 5. So this can actually be shown as branching off this. The problem is I cannot use this or this yet, since this has got 12 parts in total and this has got 15 parts representing students. For me to compare them and use them in the question, I need to have an equal number of parts in the students and an equal total number of parts in the students here. So in essence, I need to find a lowest common multiple of 15 and 12, since 12 is the total number of parts here. The LCM of 15 and 12 is 60. So how can I get 60 here? Well, I can multiply both parts of this ratio by 4, since 15 times 4 gives 60. So that'll be 4 to 60. Like that. Similarly, I need to get this here into 60, the total of male and female into 60. And to get that into 60, well, since the total number of parts is 12, I need to multiply both of these parts by 5. So that will be 7 times 5 and 5 times 5. Since 5 times 5 is 25 and the students were 60, I can just say that the proportion of female students divided by the total is 25 over 60 plus 4. 25 over 60 plus 4 is what it is as a fraction. To turn that into a percentage, I just write that as a decimal and then multiply by 100%. To the nearest whole number, to the nearest integer, that will be 39% for 3 marks. Question 19 is the final question in this video. It involves percentages of percentages and is worth 4 marks. There's 800 students at a school. Each student has either got a school dinner or a packed lunch. 31% of the students have packed lunches. 55% of the students are boys. 60% of the boys have school dinners. How many girls have got packed lunches for 4 marks? So this is a very involved question, a very complicated question. I'm just going to draw a diagram to help us out here. I'm using SD to represent school dinners and PL to represent packed lunches. So first of all, there's 800 students at the school, so let's put 800 at the top here. I'm then told that 31% of the students have packed lunches, so let's find 31% of 800. 31% of 800 is 248. Then I can find the number of students who have school dinners. Since they either have packed lunches or school dinners, there's 800 in total and 248 of them have packed lunches. I can just subtract these two numbers. That gives me 552. The next thing I'm going to do is going to find the number of boys that have school dinners. So step number 3 here. It tells me here that 55% of the students are boys and 60% of them have school dinners. In other words, 60% of 55% of 800 is how many boys have school dinners. So 60% of 55% of 800. So in other words, do 800 times 0.55 times 0.6, and that gives you 264. Stage 4 in my working, I'm going to do the total number of students who have school dinners, which is 552, subtract the boys, so subtract 264, that leaves me with 288 girls. The next section I'm working is here. It tells me 55% of the students are boys. So if I can find 55% of 800, which I can do by doing 800 times 0.55, but then remember to subtract the number of boys that have school dinners, so subtract this 264, that leaves me with 176. So 176 boys have packed lunches. Lastly, I need to find how many girls have packed lunches, and I can do that now by just subtracting the total number of students who have packed lunches, subtract the number of boys who have packed lunches. That gives me 72. So 72 students, 72 girls have packed lunches. And that question there was worth 4 marks. That's the end of this video. Be sure to check out some of the associated videos, especially on trigonometry and trigonometry in non-right angle triangles, to support you with some of the advanced questions in this video.